Hello, I'm Lorenzo, first year PhD student at the Machine Intelligence and Slope Stability Laboratory here at the Department of Geosciences, University of Padua. And today I'm going to guide you through our most recent research, which concerns the employment of the state-of-art artificial intelligence models to map landslides under thick cloud cover. Starting from the motivation that's behind our research, landslide inventories are very important because by studying past events, we can also model future events, so forecast them spatially, temporally. And if the landslide inventory is faulty or biased or incomplete, then probably our models will be biased as well. The second reason for which is very important to be able to map landslides accurately also under the cloud cover is that in some regions in the world, the cloud cover occupies the 80% of the year. And moreover, the rainfall is one of the main triggers of the landslides. And as we all know, the rainfall comes from clouds. So if we want to map promptly the landslides right after their occurrence, we have to be able to map them also under thick cloud cover. That's why in this research, we employ a special imagery, which is synthetic aperture radar amplitude imagery, which is able to penetrate the cloud cover, and so that we can get information about the landslide's spatial position, also if we have a cloud cover, as in the case that we investigate in this research. In this research, in fact, we use SAR data and artificial intelligence to map landslide in Hokkaido. In this study case, 8,000 of landslides were triggered by an earthquake. And the first open source optical image available after the event without cloud cover was more than a month after. So in this case, it was very important to map landslides with this special data able to see through clouds. And what we also did in this research was a deep investigation also of the influence of the satellite orbit when mapping landslides, because synthetic aperture radar data they are very sensitive to the topography and moisture of the soil. And depending on the orientation, there might be landslides which are more prone to be seen by one orbit with respect to the other one. There are different reasons for which we employ the state-of-the-art artificial intelligence model. The first one is that those models are able to map automatically wide areas in a short time span, while the second one is that those data are very difficult to interpret by us, because they don't look like a normal optical image like the one we acquire from our smartphone. They are quite different. So those models allowed us to map landslides on very difficult data to interpret by a human mind. Therefore, the study shows the possibility of operating a very rapid mapping 1 week right after the occurrence of those landslides, also in presence of cloud cover. Thus, the approach may have very relevant benefits when it comes to emergency operation and civil protections operation when it comes to those extreme events.